Let's get back into this. Now, this is the sub-maximal result. Now what I want to do right now is, I want to compare it using that notation of given. Given, assuming, taking for granted that, status quo, caffeine has no lowering effect on heart rate during sub-maximal exercise. We're believing that. We're believing that. So we're believing we're on that bell curve. That's the caffeine has no effect on sub-maximal exercise bell curve. What's the chance that we got lowered heart rate data? See, that's the kicker. If we were expecting not to get lowered heart rate data, what's the chance we actually did? Well, that's where the less than 5% came in, because we landed out in that tail, way out there left in that tail. Way out there left in that tail. That's the whole point. You were expecting not to land in the tail, but yet you did. The tails are the outliers, remember. The tails are the outliers. Now, you could have gotten out there in error. It could have been that you were lucky 1 in 20, the 1 in 20 that popped out extremely. Or, since 1 in 20 is so small, numerically, 1 in 20 is pretty small, yeah? 1 in 20 is pretty small. There's also a chance that it actually is lowering heart rate, and the belief that the average was up here by that bell is actually not true. It should be down here lower. More on that to come. So there's two ways you can think about landing in that tail. You could have landed in that tail in an outlier, if you will, in an outlier way. And that's what this is indicating. It's saying that, okay, what's the chance that you landed in that tail, assuming that you shouldn't have? It's less than 5%, 1 in 20. There's that cutoff, that p-value cutoff. You're 95% confident. You're 95% confident you should have landed up in the bell, but you landed down in the tail, which is a surprising or an unexpected result. Now, it could have been unexpected due to random chance. Could have been. Could have been. But it's still an unexpected result no matter what way it is. Whether it's either because of random chance or because there's an experimental effect, it's still an unexpected result that puts you down there, which makes it a positive test result. We'll come back to what that means too momentarily. Ask me questions about that, unless you're still formulating it, which is okay as well.
Well,
go.
For the rest of the values, did they test the cycles?
Hold that thought. We're coming to that right now. Thank you. Good. Other questions? I don't mean to just pause, but we're going to get to that in a moment. Decent? Okay. Now here's one more thing to think about. I want to hit the wrong way. Sorry. Back up. When you get data, this is your data right here. Now I put that on that curve with no explanation as to why it's there and not here and not here. We'll get to that on Wednesday, I promise. We'll start making the sausage grinder of data into what's called a test statistic on Wednesday, I promise. Just trust me that because it says less than 5%, I know it has to be somewhere over here. It might be down here a little further, it might be up here. I know it's in the red though. Here's the deal. When you get an experimental result from data, from your sample, you don't assume it's an outlier. You assume it's normal for that data set. So as soon as you get data, you don't go, ah, it's weird. No, you assume it's normal for that data set. So what has happened is you've gotten this crazy low result that is normal for its data set, but is unusual for the null curve. And that gives you the implication that the data set is somehow different than the null curve. The data set, in other words, is most likely centered down here, not over here. Does that kind of make sense? You don't usually observe outliers. That's kind of the definition of what an outlier is that it's not usually observed. So when you get data, you don't go, ah! You don't, not off the bat. Not off the bat. You get data and you say, that's probably the average for that sample set. It's probably pretty close to it. Central limit theorem told us that, right? Most generally, boom, you target the average of your population. So this sample is telling us, in mathematical statistical ways, that the center of its population is down here somewhere. And down here is significantly far away from up here. Is that fair? Is that believable? Believable at least. So when you witness sample data, don't immediately think it's an outlier. Compare it to your null and see how far away they are. And how far is what the p-value is measuring for you. Cool? All right. We just look at that. Now let's look at the other two. Because that was the unexpected result. Yes, the sub-max exercise was the unexpected result. Let's look at the at-rest and the maximal results. Oh crap, it auto shifted. I was going to ask you guys to predict where the asterisk should have been. How many of you guessed somewhere in there? Did you guess somewhere? Maybe not. So the idea is the p-values are bigger than 5% on those. Bigger than 5% means 6%, 7%, 8%, 12%, 50%, 80%. Say that again?
97.
It could be any of those. But the idea is if it's bigger than 5%, where is it not?
Lower end.
Boom! If it's bigger than 5%, it's not in here. So it's, can I say that? What Dan just said is very, very cool. It's expected. Can I say it a different way, an equivalent way? It's not unexpected. Then you're going to say, what the hell? Why would you say it that way? There's no reason to say it, to pick one way over the other. Not unexpected is the same as expected. We were expecting it to land in this curve somewhere within the 2 standard deviations of this null hypothesis, and guess where they landed? They landed exactly where we expected. Maybe this one was a little bit higher, but not significantly so. Maybe this was a smidge lower, but not significantly so.
How can we tell which is which? Or
It doesn't matter in this case. Dan, thank you. You will be able to tell which is which as soon as we start calculating what are called the numerical test statistics. All of these data points, the unexpected one and the expected ones, are going to have z's or t values attached to them. And we'll get to that on Wednesday, I promise you. I promise you. But right now, it doesn't matter. It doesn't matter because the only thing is that tells you that they're here. And that means that there's nothing to write home about. No news. No news. Caffeine didn't lower heart rate when you're hauling on that string. And caffeine didn't lower heart rate when you were just hanging out in the at-rest category on a flat road, chatting with your buds. Where did it lower heart rate?
The sub.
The submax one is now grayed out up there. So again, looking at it from a, well, there's a not at rest. So looking at the, if you will, probability statements, take a look at the 2 pieces of them again. Look at the back half. Caffeine had no lowering effect on heart rate at rest. Caffeine had no lowering effect on heart rate during maximal exercise. Does that right-hand side look similar to the previous one? When it was caffeine had no lowering effect at submaximal exercise. They all look the same, right? Except we're just editing them for the different levels of exercise. But the difference is what happens before that. What happened at rest? We got what we were expecting to get. If you got what you were expecting to get, what didn't you get? The unexpected. You didn't get an outlier. Stacy?
I'm just wondering because you're doing this test, like so it's saying that when you're not at rest, it's not lowering it or anything like that.
You might be raising it, but not lowering it,
Yeah,
sure.
so if it's raising it and then it comes back down during submax.
Well, we're not testing raising. We don't even care if it raises it. What we care is if it drops low. We're expecting it to maybe raise. So if it goes up, if it's going up, we're like, whatever, just let them keep pedaling.
But if it goes down from that up, that's not considering low.
But it has to come through average first.
Okay.
So yeah, if you go up from average, in order to go down, it has to come down, but you're still above average until you get 2 standard deviations below average. But at that point, you're going from 180 beats per minute to 70 beats per minute. You gotta check the guy for a pulse at that point. But yeah, you have to pass through average first to get to the unexpected limit. That is a very good question. So it's not just down from max, it's compared to average. Compared to average. Always comparing that, well, the curve is missing now.
At something.
Yes.
So see that-
Well, compared to the average, the null average, which is whatever their average heart rate is. The idea is you know what these guys' average heart rates are before their tests. You know what each one of them has an
I
average
say
heart
each
rate.
average is different. It's not like the average for all male, blah, blah, blah.
But you can compare it to that, and here's why. Those guys are so... When you think about the level at which these guys compete, elite male cyclists, that's why they do EPO. Because that gives them a little teeny tiny advantage over the next to them. But the problem is, so many of them are now doing EPO that that's what's being called a level playing field. You can't compete naturally, basically, anymore, and expect to win any races.
And EPO is that cleaned out blood thing?
That's the taking the blood out, training at altitude, putting it back in when it's highly oxygenated. Yeah, it's not actually drugging, it's doping. So the idea is, it's the same reason when I go back and mountain bike with my friends in Delaware, I kick their ass. Because I'm riding my bike even at 5,000 feet, 3,000 feet, 4,000, I go down to 0. I'm like, what's wrong with you guys? You're like, "Bleh." Because my blood is doped, essentially. I mean, I'm ruled out by the UCI. But they have an average, and they're so tightly averaged that you can actually just throw them all together into one big loop and test them like that. You can, if you need to. Fair enough?
Is that why a lot of elite hikers would want to live in a higher altitude?
Absolutely. Like Spain, Boulder, Colorado. Oh, absolutely. Absolutely. For sure.
The
For sure.
average for maximum and the average for sub are different, that's what I'm saying. It's
Oh,
not-
correct,
It's not
correct.
the average is
Gotcha.
the average.
Gotcha. Yes. Exactly. Good questions. Other ones. Keep them coming. Those are fantastic. We good? Good so far? Goodish. Maybe still kind of getting our fingers around. Don't worry about where these numbers are coming from yet. The whole point of this is not to get yourself worried about the T's and the Z's. All of these have what's called a test statistic attached to them. Just like there was a critical value in the confidence intervals, these have a test statistic. But don't clog yourself with that right now. I want you to focus just on what this is telling you. The big takeaway at this point in the game, if you see a bigger than 5%, that means you didn't get anything unexpected. You got what you were expecting, which means you can't write a paper about it because it's not unusual. Bigger than 5%, can't write a paper because nothing unusual happened. The reason the paper exists is because the sub-max popped out at less than 5%.
Unless somebody else wrote a paper about it and you're saying, no.
I'm treating your study in isolation, Dan, but you're right. You might want to counter-prove it, for sure. But as far as a new idea, you can write a paper about it if you get your unexpected results. And these are not unexpected. Expected, greater than 5%, within 95% confidence. You're in the interval. In other words, you established a confidence interval on a parameter, and you're still in it. Nothing's changed. This is why Gallup pisses me off so much. Obama's approval rating dropped 1 percentage point. What's your margin of error? 5 percentage points. How could you possibly know that? How could you know it dropped 1 percentage point if your margin of error is 5 times as big as the drop you claim? You can't, can you?
What if their margin of error is always the same though?
It usually is at
The interval
3%.
goes down?
Now, the question is, how far did it go down? How far did their p-hat go down? If the margin of error is 3%, and the interval drops, or the p-hat drops more than 6, then I'm like, okay, we got something to talk about now. Because now you're arguably outside of a margin of error on either side. But if if it doesn't drop more than 6%, we're talking about no change at all. Does that make sense? Imagine your intervals
Right,
go, yeah.
But it's still way lower than the newly elected president.
Oh, God, yeah, I'll compare them from 2000, whatever that was, 8.
So from somebody who never read about it.
But the problem is Gallup goes week by week by week. That's ridiculous. That's just filling out newspapers, essentially, with meaningless drivel. Yeah, good. That's why, as much as I like to believe it, that Congress is less popular than syphilis, I can't. Because it's 9% and 10% with a 3% margin of error. So, it's unfortunate.